Hi, my name is Cameron McGhee. I'm an ECET497, fall 2012, and I'm going to demonstrate my components for the 300 watt Class D audio amplifier. As you can see, everything is all put together. It's in a more permanent and stable state than just being breadboarded or anything else, or just being free laying around on this board. What we're actually looking at is, with the exception of speakers and a cabinet and different things like that, this is actually the inner workings of my amplifier. Off here on this side, this is just the wire connections for the power supply, and from the for the transformer. It's taken apart for the most part, but we just have the wires and different things from what comes in from the AC wall right here. We have a for testing purposes, just a metal chassis for grounding, just for testing purposes. And then here is a huge bulky 1000 watt toroid transformer. I selected this transformer just for the possibilities of its performance capabilities beyond the spectrum of ECET496 and 497, and what I would hopefully like to do once passing this class, which would be to maybe build a much larger amplifier system. Of course, it kicks out about 1,000 watts, and this project only calls for 300 watts. So there are greater possibilities as far as power and audio power once this project will be completed. For the time being, what it does is it kicks out, after it's transformed and rectified and everything here, it actually produces about 75 volts DC, plus and minus 75 volts DC, which leads me to my next portion. Right here is it's a rectifier set right here. It has the four rectifying diodes within it. It's one part. It's a looks like an NTE 53222. And with that, after the voltage, we get the output DC voltage. Excuse me. After that, we have the capacitors here, which regulate the DC line. These are two bulky 10,000 microfarad 63 volt capacitors, but they work well up in the range of 75 volts, so that's not a problem at all. And from there, we have more regulation of the power supply output voltage. For the purposes of this project, I don't actually need 75 volts. As I said, looking ahead, it provides what I would like to do after 496 and 497. But for the time being, I only need about 45 volts DC, 45 volts DC, 15 volts DC, plus and minus 5 volts DC, and that's all the voltage that I need throughout this project, just to power the entire amplifier system. So we have regulation here. We have some Zener diodes in here. Can't quite zoom it in, but right here, and then right here, these little red diodes right here, that actually holds the voltage to 15 volts. So for the purposes of powering my post-width modulation system, and actually providing the gate voltage to the MOSFETs that I'm going to use, which aren't these MOSFETs at all. These are just regulators. and we'll get into that a little bit later. But these diodes, they basically hold the voltage at a level that I need for the MOSFETs, the driving MOSFETs, the amplifier. These regulators, this one is a 15 volt plus 15 volt regulator. I don't need minus 15 volts. So along this side here on the left hand side, this is all the positive voltage, and then on this right hand side, this is all the negative voltage regulation. So as you can try to get a better look over here. So right here, this front regulator is a negative 5 volt regulation, and that's just for powering the amplifiers, the op amps, and some of the other ICs I have in the project. That's just, it's providing enough headroom for those to operate as desired. And as I said, this is a plus 15 volt regulator, and this is a plus 5 volt regulator here, and that provides a positive power, of course. What we have on this side over here, we have some potentiometers. These serve as volume knobs. Once in its final form, there'll actually be knobs placed over these two, and of course that provides the user volume control and everything like that. And let's see, moving forward, we're starting to get into the actual amplifier and the way the audio input signal is just sort of manipulated through the circuit. Over here we have a summing circuit. It's a negative feedback circuit. So these resistors just kind of sum, basically just sum the two input signals, which I failed to mention here. These parts here, this is where my two separate audio inputs come in, and the whole purpose of this project is also so that I can use multiple inputs to go through just one speaker, basically, if desired, or multiple speakers, which I will eventually have by the end of this course. So these resistors right here just kind of sum together those audio inputs, and then this IC right here, say it's a TLO84CN, and what it is actually a op amp. So this serves the purpose as a preamplifier for the audio amplifier project. In this circuit right here with the resistors, there's some power loss in there when summing those two signals together. So this brings the lost power back up, and that's what this resistor right here is in place for as well. This is bad lighting. I know it looks sort of kind of everywhere. There's a lot of different things going on here on these PC boards. These little blue nodes right here, these are just connectors for the wires. It makes it a little bit easier for testing, or if something goes wrong, instead of desoldering everything, I can just simply remove the wire from those jacks right there. Okay, so and you'll see those a little bit more on this board here, and here, and then also over here on the Class D audio amplifier side. So what I also have here are two op amps for the pulse width modulation. Three op amps for the pulse width modulation block of the Class D audio amplifier, and then just some capacitors, resistors, and one diode in there just to control the signal, the PWM signal. More wiring, like I said, capacitors, and there's a diode in there. And then starting to get towards the conclusion of this demonstration, first I'll start with these pieces right here. These are actually the MOSFETs that are used here. This one, it looks kind of rough on the video, but it's just soldering, or I'm sorry, heat sinking grease on there. But these are the MOSFETs that are used for the switching MOSFETs, I'm sorry. And what I'm using there are IRF 3710s. I chose those just because of there's low loss, there's a low on resistance, very, very low on resistance with these MOSFETs, so there's very little power, very little voltage loss at all, if any. When it passes the voltage, it literally passes that voltage, and that was a plus. And then also it has a high power handling capability. Voltage handling capability up to 100 volts. And as I said before, for this project, I'm only using 45. And then eventually I'll probably end up using the full 75 for a much larger project. But this is what's first and foremost. These two circuit boards here that are kind of hooked together, this is the switching parts of the amplifier. What I have is a full bridge Class D audio amplifier. So I have some MOSFET driver ICs in here. There are also international rectifier parts. I chose those because of, once again, their high voltage handling capability. I have capacitors in here. Show those capacitors. Diodes in there. And there's a lot of wiring and just kind of connecting everything together, really. And then also a set of inductors in here, this one and this one, for the filter. And then also more capacitance. And this is for the full bridge. So what I guess I had in my mind is one PC board serves as a half bridge. So this actually has basically the half bridge. It has the two MOSFET ports, or jacks, I should say, right here. Just that I kind of put those together myself, just so if I burn through MOSFETs, I don't have to desolder MOSFETs. It's easier to just pull them out. And I did the same thing on this side as well. So, and that's basically it. I also have no, I don't have that at the time. So yeah, that's basically it. So this is my Class D audio amplifier project. Once again, my name is Cameron McGhee, and this is for ECET497, the 300 watt Class D audio amplifier.